there are situations where there can be some ambiguity because if you look down here, the main thing I want you to focus on here is that A is between the height of the triangle and the other side that's given. So when we're given two sides in an angle, this is a possibility. It's not guaranteed that it's happened. So far, as I recall, we haven't done one like this that actually worked out this way, but I might be wrong on that, but I think this is the first time. And so in this situation, we get the sine of 20, which leaves a lot of room for other things to be going on. And turns out other things could be going on. So our calculator tells us 64.8 degrees, but there's another angle in quadrant 2 that's a possibility. Okay, so, and it turns out both are possibilities because if we go, let's see, will they show us down here? Well, it shows us, it goes back to the A is between the height of the triangle and B. So we're going to lean on that to see if our situation is like that in our problem. And if you go back up here, will they show us? I know they will, I think. Well, we'll certainly do it. Oh, here, up here it said, notice that the height of the triangle is equal to the hypotenuse B times the sine of A. And we're going to do that to see if our situation lines up with this example. And I'll, spoiler alert, it does. So we say to ourselves, okay, the sine of A over the side, well, I might as well, they tell me it's 58, I should say 58. The sine of 58 over the side A is equal to the sine of, I don't know B, and I don't know what this triangle looks like, that's part of the problem, 12.8. Okay, so when I multiply this out, I get 12.8 times the sine of 58 is equal to 11.4 times the sine of B. Okay, and I divide both sides by 11.4, and I'll do that real quick on my calculator. I get 12.8 times the sine of 58, which is about 8.4. Oh wait, that is the sine of 58. I have to multiply by 12.8, and then divide by 11.4. And so I get the sine of B, to switch sides, is equal to 0.952, we'll say 2. Okay, so arcsine time. Oops, I hit arctangent. Why? Okay, go back. Arcsine is 72. So we'd say B, it's very possible that B is equal to 72 degrees and 2/2100ths of a degree. But there's room with 58 degrees and 78 degrees. So let me just finish this idea. We have 58 degrees. They gave us that. And then C would be equal to, what would C be equal to? We'd say 58 plus 72, and we'd subtract that from 180. So that in this situation, C would be the leftover degrees of 49.79 degrees. Okay, that's case one. The other case is if we take our 72 degrees and we subtract it, and we from 180, and we say, hang on, B's not, we're not talking about a quadrant 1 idea here, we're talking about a quadrant 2 idea. So 180 from 172, and now B is this oblique angle here, obtuse angle, 79 degrees there, and we already said A is equal to 58, and then what does that leave for C? Not much. So we'd say plus 58 leaves less than 15 degrees. C would be 14.21. And it's really tough to draw this accurately, so I don't think I'm going to attempt that. I'm not much of an artist anyway. But you can see these are quite different. You know, the first case, everything's it's not an equilateral triangle, but it's a lot closer than the second case, which is wildly unequal. This one is all over the place. Big one, big angle, little angle. Okay, so, but the main thing here is that we think about, and again, pardon me, this isn't going to be quite like it should be, but if I draw this, I shouldn't be trying, but if I draw this like this, see, that's no good. That's no good. But let's just say that this is B up here. I didn't really want to do that. And we'll say this is A. See, my drawing is really hindering me from showing you like I want to show you. I really want it to be like their example, where A is down here. And see, but then C gets to be too big. I'm sorry. C gets to be too big. So maybe I should restrict C a little bit more, and then I can live with it better. Okay, so here's A, here's B, and here's C, if you can believe that. And here's my height, that's H. And so since I made a right triangle here, and this is side B, then I can say the sine of 58 times the hypotenuse is equal to the height, right? Okay, and I know B, and I can find H. So they tell me that B is 12.8, and the sine of 58, and I multiply that together, and it turns out that the height is 10.8, we'll call it 6. Okay, so this is the situation they're telling me about. They're telling me that H is less than A, which is less than B. Okay, and that's exactly what happened here. The height is 10.86. A is 11.4. And B is 12.8. And so fix this in your mind here. A is between H and B. So let me go back up to their scenarios here. And that's what we have. We have A between H and B. So because we have that, we know there are two solutions, and we're going to go ahead and solve for both of these. Even if we have a great deal of difficulty drawing them, we know that they both exist. So we're just going to use the law of cosine, or law of sines for both of them. And let's go ahead and get started on that. We'll keep these cases separate, but we will say, did we find... So all we really have to do now is find C. We know A, we know B, we just have to find the side C. So we can say the sine of A, and again, I should just say what I mean. The sine of A is the sine of 58 degrees over side A, 11.4, is equal to the sine of C, 49.79, over C. Okay? So I'm going to spare you writing this all out, and I'm going to say 11.4 times the sine of 49.79, and then divided by the sine of 58, and that gives me kind of a reasonable answer here for C, 10.26, well, 10.27. All right, so this solves for everything. I have all the sides, I have all the angles. Okay, let's go over here and let's try this. The sine of 58, sine of A, over A, is equal to the sine of C, which we say over here is 14.21 degrees, over C, and let's find out what C is here. So in this situation, we have 11.4 times the sine of 14.21 That's about 2.798. And then I'm going to divide that by the sine of 58 to get C. And so, so when I do that, C is equal to, well, it just rounds up to 3.30. Okay, so that makes sense. Smaller angle, smaller side. And so these are both possibilities, and we don't know which one it is unless they give us more information. I suppose that's what we'd say is the key here. We need more information to discern which triangle we're talking about. And I suppose we had to find the angle for B as well. So we have two situations, and both are tenable, and they would have to supply a little extra for us to know which one they're talking about. So this is not a nice situation, but just want you to know there's possibilities when this occurs. When A is between the height and B, then two things can happen.